Hello and welcome everyone. In this video we will discuss the quality definitions and the concepts in Six Sigma as they are in the context in the textbook. The objectives that we have defined for this module include the definition of quality improvement, the discussion of the dimensions of quality, the discussion of the evolution of modern quality improvement tools, discussion of the role of variability and statistical methods play in controlling and improving quality, describe the quality management philosophy of quality gurus, discuss total quality, Six Sigma, quality system and standards, and finally understanding the DMAIC methodology. All these learning objectives include the material that is in chapters 1 and 2, and that's what you need to read during this first week. The definition of quality has evolved. Traditionally, it was fitness. It has the product or process had the fitness for its use. That's a traditional definition. However, it doesn't help us much because when you think about, maybe you're buying a glass, this glass could be a plastic glass, could be a disposable plastic bag, it could be a non-disposable plastic glass, it could be crystal glass. So depending on what the use is, you would have different, and then also how much is the customer willing to pay. So now the variability is too much to really compare qualities. So a different approach to this is what we're going to be using, which is quality is inversely proportional to variability. And that's what the book is about. That's what the most successful methodologies for quality have been working on for the last several years. And to have a better understanding, let's consider the traditional versus what is known as Taguchi loss function. Taguchi is one of the pioneers in quality in Japan. And it used to be that for a product to be, let's concentrate on the left-hand side of this diagram, for a product to be within quality, it was enough that it was between the specification. And if it was between specifications, then the product will be okay regardless of where it is. You have a target in the dimensions, for instance, and if you are fluctuating around the dimension within the specifications, then you're fine. Only you have a loss if you go beyond the limits for those specifications. On the other hand, you have Taguchi approach. The Taguchi approach is you only minimize the cost if you are in the target. Any minimal fluctuation around the target begins to create problems. And that has been proven. There is an example in the book about transmissions and how the same product manufactured by two different suppliers, one with lower variation and the other with higher variation. The product with higher variation created more problems because you begin to have to reprocess product and problems in the performance of the product in the field. So it is important to reduce variability, and that's what we're going to be discussing through this course. In the discussion of total quality management, one good distinction that I like to point out is we can do the right thing and we can do the wrong thing, and also we can do things wrong or we can do things right. We only perform correctly when we do the right thing and we do it right. But many times, many times, we find ourselves doing the wrong thing, but doing it right. And the question is, what is this wrong thing that we do right? For instance, let's say you have a punk tire and you have to change the tire, and that would seem to be that is the right thing to do at the moment, and if you do it right, then the tire will work well. But if you think in terms of quality, changing the tire is a wrong thing. And it's a wrong thing because you shouldn't have never had that problem with the punk tire. Usually these type of situations happens because you hit something on the road, you were too fast, you're going too fast, or other problems with the performance of the tire. There was a nail, and anything that should have not happened, and it could have been prevented. And because it could have been prevented, it should not have happened. And therefore, every time we have these type of events, we feel ourselves reassured that we are capable of dealing with these events. And this is what in the industry is known as putting out fires. But we shouldn't be doing that in the sense, not that once the fire is presented, we should not put it off. But what we should be working on is to avoid fires. Imagine that every other day the building or the house that you live is on fire. That's not the right thing to happen, right? There are construction codes, and then there are behavioral situations in which we engage in order to avoid fires. Well, the same thing should be happening with everything we do, both in industry and in our lives. And only when we have a larger amount of doing the right things and the things right is when we begin to improve the quality of our lives. Otherwise, we're just struggling with the everyday burnout when we're trying to solve the next new problem. Interestingly enough, there has been statistics on how much time people spend on doing these different 4 types of things, and only a minimum part on the ranges between 15 to 20% of the time people actually work on the right thing and do it right. A lot of the time, a lot of people just spend, as I mentioned, putting out fires. Usually this happens because there is no planning, there is no prevention plans, there is no quality programs. Now, sometimes we do the right thing, but we do it wrong, and that could be because we're developing a new process, we're learning. But if we are doing it, even if we fail to get a success development, it could be the right thing because it's the only way to learn, right? So as long as we could be getting an error message if that's not the right answer to our problems, but it could be still the right thing and the things right if we are learning in the process. The problem comes when we, as I mentioned, we are comfortable thinking that we're being successful in quality when we are only putting out fires. Now, with the Six Sigma methodology, we have the capacity to, or the idea of reducing variability by means of projects. And what happens is that when you read the literature, you see that they're talking about 3.4 parts per million in the number of defective. Now, this comes as a number that it is hard to find where it's coming from originally. Well, the idea is at 6 sigma, you only have 0.001 parts per million defective. And but the idea is that even if you have a change in the process of 1.5 sigma in the mean of the process, you still would be at 4.5 sigma standard deviations from the limits of the specification, and that would generate only 3.4 parts per million. Now, this is achieved not by extending the specification limits, but by reducing the variability. What we really want is to reduce the width of the normal distribution by making sure that the process repeats again and again. So the definition for quality improvement, both in the book and for the course, is the reduction of variability in the process and products. and there is an example of a transmission that explains that, and the topic that I just mentioned. So with this, I just finished this video. Please read the chapter in the book